So we know we have a few more people in the lobby area, but we're going to get started. Good afternoon, everyone, and welcome to today's Tuesday Times Roundtable. My name is Janeri Mendoza-Farjan, and I'm the Senior Program Coordinator at the Office of Global Learning Initiatives. The Tuesday Times Roundtable is the Office of Global Learning Initiatives flagship discussion series that brings together multiple perspectives on global issues and trends. With us today, we have also our team. So I just want to give a shout out to Rola. Thank you for joining us today. Michelle Saldivar and Dr. Landorf as well. Thank you so much for joining us today. As a reminder for everyone, so the QR code is also here in the screen. You got a moment to scan it in the lobby, but also feel free to do it in here if you haven't done so already. Whether you're here for Global Learning Medallions points, honors college, extra credit from your professor, or whatever brought you to us, we're just happy that you're here engaging in today's session. The topic for today, it is Tangled Triggers of the Global Cancer Landscape, the molecular fallout of environmental mixtures exposures. As a reminder, as we engage in the session, we're going to have microphones in the lobby, so just raise your hand, and that way one of the team members can bring it over to you. That way we capture your insight also in the recording. Okay, also today's topic is connected to the New York Times article. And this is because FIU has a formal partnership with the New York Times, so everyone with an email address from FIU gets free digital access. So feel free to go to go.fiu.edu/TTR 1007 to access the article for this week. And we also connect our Tuesday Times Roundtable to the Sustainable Development Goals. Today's session connects with SDG number 3, which is good health and well-being by ensuring healthy lives and promoting well-being for all ages. All right, and now it is my great honor to introduce today's presenter, Dr. Alok Deoraj. He is a teaching professor in the Department of Environmental Health Sciences here at FIU at the College of Public Health and Social Work. A little bit about him. He is a distinguished member of FIU's Global Learning faculty and an affiliate of the FIU Honors College. He earned his Master's of Science degree from Patna University in India, his PhD from the National Institute of Immunology, Jawaharlal Nehru University, and a certificate in business management from Belmont University in Nashville. With an extensive experience across academia and the private sector, he specializes in teaching global and environmental public health at the undergraduate, graduate, and doctoral levels. His excellence in teaching and service has been recognized with FIU Faculty Awards in 2017 and 2019. He had published more than 70 publications, and his focus is on molecular toxicology, examining cancer risks linked to environmental exposures, such as endocrine disruptive chemicals, heavy metals, and microplastics. So let's give him a round of applause.
Good afternoon, everyone. I guess everybody can hear me over there. Everybody. So I'm so glad to be here. I have earlier, I think a few years ago, I have given this Tuesday Times Roundtable, and it had been some time, so I thought, okay, this is the time again to get back here. So today's topic actually, as we can see here, tangled triggers of the global cancer landscape. I don't have solution. I don't have how we can untangle these kind of signals what we get from the environment, which can cause cancer, which can develop cancer, which can even aggravate the cancer. So those kind of things. But let me just go to the next slide here. Okay, so let me ask you this question. What environmental factor or you are exposed to regularly that you are curious or concerned about? Raise your hand and tell me. Yes? Microplastic. Okay. Anybody else?
Air pollution.
Air pollution, okay. Anybody else? Go ahead, you. Yeah. Yeah. UV radiation. Anything else somebody wants to add? Yes, go ahead. Heavy metals, okay.
Heavy metals.
So, there are so many environmental factors, the chemicals, and so many things which is there. And every day, the time you put your brush in your mouth until going to the bed before you are washing your face, think about it, the number of chemicals you are exposed to. It's no less than 3,000, 4,000 chemicals you are also getting exposed to, besides the other things, the food you eat, the water you drink, the air you breathe. So you are actually getting exposed to all kinds of things. Of course, the microplastics has become much more prominent lately. Everybody is talking about it. And along with it, also, we are talking about PFAS and all these kind of things. So these all together, you are swimming into these kind of things. And but what does it do to your body? How it gets into you, or what it does, actually. So do you think you are contaminated? Okay, so this is also based on this article, which is, which we, from the New York Times, what was there. So you are contaminated. And actually, there had been a dramatic rise of the toxic chemicals. And as you can see on this graph from 1940s around the World War II, since then, there had been we are almost on an yearly basis, we have 100,000 chemicals in the environment. We are producing more or less every year a couple of thousand of new chemicals, which also includes pharmaceuticals and anything which we are thinking that's kind of improve our quality of life. But unfortunately, we don't know the toxicity of many of them. It's hardly 3,000, 4,000, maybe 5,000 chemicals. We know the toxicity, but that too, that it's so much of different ways the toxicity can go. So we don't have a clue that how they're actually affecting our body. And then it's very hard to catch up with it. Every day, for example, we have one of our graduate students, Sharika, is working currently on the PFAS. So you have a short chain, long chain, and then you turn around, and then they're supposed to be making it much more safe. But then after some time, you find out, oh, that is also it's a toxic. So those kind of challenges what we have. And as you can see here, that there has been a lot of dramatic rise into kind of chemicals what we use. Now here, what I would like to just show you that we have environment where what we get exposed to kind of pesticides, fertilizers, stressors, smoking, alcohol, diet, nutrition can affect certain genes. Those genes may have different kind of functions. And then from there, they create certain traits. And those traits can generate certain phenotypes, and then that has a health outcome. But again, some of them, those exposures could be beneficial too. It's not necessarily always it's bad. What kind of exposures you are getting that may have even protective features. But this is the kind of a tangling what is happening. And as you can see, breast cancer, low birth weight, or cardiovascular disease, just some of the health outcome I'm presenting there. But our focus is going to be on cancer today. That how those environmental factors and those things which can cause cancer, develop cancer, and how it can further aggravate the situation. Now, think for a moment about someone you know here or abroad who has suffered or been lost due to cancer. Yes, go ahead.
Hi. Just from the previous slide, based on that, I just have a personal question, as a researcher and as a professor, what is something you avoid, in your environment, smoking or in your diet or something, what you think is the most harmful?
We will be getting into that. We have it's just
okay.
a very, yeah. There are so many things. It's very hard to pinpoint, and that is where I'm going to bring that problem to you. What do we do? So I don't have a solution.
What do you do?
And it's just not chemical. You will be surprised to know that chemicals are there, but they only contribute 2% towards developing cancer. What is the most important is your nutrition. The nutrition is 35%, which contributes to the cancer incidence, as well as smoking. That is about 30%, smoking, which contributes to the cancer. 2% only is the chemicals. So I'm sure that everyone you touched with the cancer, a loved one or anybody, the family members and all those whom you know. And that is why, I focused primarily on the cancer today. And this is, again, what I'm going to show you here is some of the data which I pulled out from the comparative toxicogenomic database. And as you can see, these are the list of disease categories, which is based on the exposure to the agrochemicals. And this is, again, there are different categories of chemicals, the agrochemicals, which includes fertilizers, pesticides. Then we have endocrine disrupting chemicals, carcinogen, mutagen, which is known to cause cancers, which has been, here, it's a curated and inferred association by different database analysis. That's how you do. But as you can see, the cancer is more or less on the top. Besides all the kind of disease or disorder what you see here, the cancer is more or less on the top. So endocrine disrupting chemicals, you can see it's only 5th or 6th in the ranking. Agrochemicals has been associated with the cancer at more or less at the top. So before I go into detail, I also want you guys to know, these are some of the terms. Exposomes. The exposomes encompasses all environmental exposure in individual faces across their lifetime, impacting health. Environmental contaminants, we will come to that. What are the environmental contaminants, how they can contribute, some of the scientific evidence, what kind of a scientific evidence we have, whether it's a laboratory or database analysis or how we can analyze that, and policy and personal agency, understanding exposome impacts, informed public policy. And so because as a scientist, when we find out that, okay, let's say the lead, for example, 20 parts per billion is harmful. But tomorrow when we find out, oh no, it's 10 parts per billion itself is disastrous. So that's how that information feeds into your policy change. So we can influence the policies based on our scientific evidence, and that can influence the policies. So these are the kind of a direction when we learn, when we do the research and we go forward with that. So now, look at this picture. And what comes to your mind? Anybody? Chaos. Okay. I can't interpret it. I want you to interpret it. I'm sorry? Electrical wires? There are some yarn too, some rope.
Oh, it's on. Oh, it looks like a veins. Yeah, that's what it looks like.
It looks like everything is tangled together, and it's hard to isolate a single thing.
Here.
It has many veins on them, and trying to, I guess, multitask with the task they have to do. It reminds me like a brain for some reason.
Okay. This is the kind of a tangle we have to resolve or untangle in terms of understanding the cancer. Because the different signals from all kinds of direction it comes to. We don't know many of the signals what we don't know. And actually, I would say that this is just not cancer. Any chronic diseases or something, it applies to anything, whether it's Alzheimer, whether Parkinson. And that's a challenge. That's a complex situation what we have. So how do we figure out? What do we do to figure out that what's happening here? How do we untangle it? That's the question. Even you see that, you can tag it. You can see where it is going. But then some other one comes, and then that can either nullify or even it can aggravate the situation. There will be synergistic or antagonistic activity or actions will be taken into that. So my talk will move towards the exposure to environmental pollutants alone or in a mixture influences the expression of key genes that are regulated by a network of pathways associated with adverse health outcome and cancer development. An adverse health outcome, when I say again, it applies to most of them. But since my focus is going to be on cancer, that's what I'm going to be talking about. So this is just some of the data which I would like to present, some of these global trend in cancer. This is from the Global Cancer Observatory. This is IARC. It's a UN organization which does this. As we can see, it's a 2022 data. It was 20 million. By 2030, it's going to be 24.1 million. And then lower is the upper one is the incidence. The incidence, what is going to be increasing. Yes?
Based on that, do like in the past, were there less people with cancer, or do we just have less data?
That is also true to some extent. And here, now we can monitor, and these are all based on the cancer registry. So many countries even don't have cancer registry at the moment. This is based on 183 country data. But then many countries, they don't have. And many countries that are still trying to come up with it. So you have to take this data as a salt of grain, like a grain of salt, because some of the data may not be as good as it appears here, but this is from one of the more authentic data center from where we have got this one. This is from the IRC, International Agency of Research in Cancer.
100 years ago, there were less toxins. You say there were less cancer patients?
Well, Diana, would you think that in less than like in 100 years, did we know about many of the things we are also learning?
We've gotten better in detecting cancer.
Right.
Oh, yeah. Sorry. So I think with technologies, we've gotten better in detecting cancer. So the incidence that may also play a role, but when it comes overall trends, there's more people having cancer due to environmental exposures that they didn't have years ago. There's clearly a trend. I mean, right now we know there's an increase in colorectal cancers in young adults, which we have never seen, 20, 30 years ago. So clearly that is there. There's an increase due to environmental exposures.
Thank you. So actually this is, as you can see here, the incidence is increasing, but what is happening is death is going down. Because of the early detection, because of the treatment, because of the management, that's what is happening. But that data also doesn't apply to everywhere in the world. Some places, like, death is skyrocketing, and some places, the percentage of people are dying and all that. So the incidence, definitely it is increasing. And as you can see here, this is also projection all the way to the year 2050. You can see incidence, male and female on the top line, and the lower one is the mortality, males and females. You can see that still the incidence is going to go up, and the environment plays a big role. I mean, overall, if you think all the diseases, the chronic diseases, 75% of the diseases can be directly related to the environmental factors. So this is 11 most frequent cancers. Non-small cell lung cancer, colorectal cancer, breast cancer, glioma. So as we can see, most of them. And as Diana just pointed out, our cancer death rate is going down. But the worrisome thing is that it is being detected much earlier in the life. Even the adolescent and young adults, they are being detected. And recent data suggests that the colorectal cancer is one of the very, very high into the young adults. So this is the US trend in cancer, new cancer cases 2025. This is again cancer death, as we can see here, national trends in rates in new cancer cases. Here you see, you can, even in this one, there is a decline in many of the cancer, but some cancer there is still rising, the either incidence or the death. So, coming back to her question, so there are so many things in our environment, and it's everywhere. As you can see here, that it's an environment, indoor, consumer product, air, food, water, people who get that. And then you have endogenous exposure, exogenous exposure. Endogenous exposure is that whatever you eat, whatever you get exposed to, that changes your internal environment, and that affects your outcome, the physiological outcome, whatever that happens there. So what happens with any exposure, let's say, for example, of the chemicals, when you get exposed to chemicals either alone or either like in combinations, they do something to your body, and our body does something to them. And that is one of the processes, detoxification. But if it overburdens, then it starts to have its different effects, such as oxidative stress or the toxicity pathways, and then that may even lead to cancer. But they do something to our body, and then our body does try to do something. And this is how you can see environmental pollutants, cellular toxicity pathways, organism adverse health outcomes, and then you can see here organism, population, and ecosystem. So it also affects like the chemicals and all that, what is there in the environment that affects the ecosystem as well. So some of the pollutants you did mention, but can you list some of them what we get exposed to? Some of them emerging ones, and we already talked about PFAS or some of those things. But here, plastic, PFAS, endocrine disrupting chemicals, nitrogen phosphate fertilizer runoff, pharmacological. This is a big one, pharmacological runoffs. So the medicines what we take, the antibiotics, or you can see all the expiry medicine, all those goes into our water bodies, groundwater. It contaminates our groundwater system. Wildfires, the particulate matters, lead, viruses and bacteria, pesticides, mercury, toxins, dioxins, alcohol. And this is not all. This list is not exhaustive. This is not complete. We get exposed to so many other things. These are our environments, as you can see, whether our recreational place, whether occupational place, where we work. If you are living in this kind of a situation, here at the beach, this is the person who is working on the ship, and this is Flint water system. So these are the environments where we live. You can see these are the environment of the big cities. Our environments, the war and conflict zones, slums, refugee camps, war zones, metropolitan urbanization, blizzard, flood, drought. So these are the environments where we live. And all these actually present different kind of a situation here. Different pollutants, different environmental chemical, different stress, which also causes the effect on your physiology. And then this is also very important, that our exposure varies from, let's say, birth all the way to the 65 years. This is the chart we have. And then you can see where do we get exposed to? Intrauterine, breastfeeding, soil ingestion, food, dermal, occupational, domestic environment, air, water. So this is where at different stages we get exposed to. And the outcome or the exposure, how it affects our body, how it affects our physiology, the genetic makeup is all dependent onto the age. When you get exposed, so children are much more prone to have its effect much more than the adult. But because of this, just think about their small size and the surface area. If there's a particulate matter or something which is there in the environment, the per centimeter area will have much more pollutant they will be exposed to. The adult, the immunologically compromised, the pregnant women or the elderly people, they will be also exposed to, and they will have much more difficult, deleterious effects. One of the most vulnerable time period is, of course, the baby in the womb. Because think about it, that's one of the fastest time of the development. The development what takes place into the baby in the first 9 months of the womb never happens throughout your life. So what will happen? Any exposure to the mother or through the food, through the water, so that the probability of introducing any kind of interference is much more higher because cells are dividing at such a faster rate. And that introduction of that, whether it causes carcinogenic activity, whether it causes mutagenic activity, it may not show up right away. Sometimes it does, but sometimes it may not show up at that time. That manifestation you can see 20 years down the road, 30 years down the road. Because essentially what you're trying to do is that you're trying to reprogram the whole thing. So that's one of the most vulnerable age. The second vulnerable age is actually adolescent time. there also there is a faster growth rate which is taking place. So that's when also whether it's smoking, and that's where we are much more aggressive. We are also trying to do new things and those kind of things. So that also affects, because that's when the development is taking place, especially reproductive development which is taking place. The introduction of the mutation or the epigenetic effects which goes in there from 10 to 24 years of age group. So that's a very, very also another vulnerable age. And then, of course, as you go elderly, you don't have capacity to process it. So that has its own effect too. Then the women, the reproductive age, or even after menopause, so that's another areas where any exposure of which has deleterious effects, which is much more pronounced. So this is just to give you an example. The endocrine disrupting chemicals, as you can see, it's everywhere. The plastics, or the natural chemicals, phytoestrogens, consumer products, parabens, and all these what you have everywhere. So now the question is, how you get exposed? What are the exposure routes? Inhalation, ingestion, and touch. We are very porous people, so we get everything, even the emotions we imbibe, or we just take it. So that's ingestion. That's one of the main routes of exposure, how you get exposed. Whether you are drinking, whether you are eating, anything. So that's the most important, and the most how you get exposed to. And this line is from the article. Every time we pant or press or swallow, we welcome into not just our delicate biology, but into those cherished fables to the ecological influence of exposures. This is from the article. So the question is, how do the mixture exposures play a role in the initiation, maintenance, and aggravation of cancer? And what are the tools that can be used in establishing the roles of mixture exposures? And if you ask me, I don't have any answer. Again, back to here. So this is, again, we have to untangle. So it can lead to any direction. This, as you saw, that all this signaling which is coming from all different kind of exposures, where they are going to be activating, which kind of a signaling transduction which is going on into which kind of cell, whether it's a beta cell of the pancreas, or whether it's the ovarian cells, or whether it's a breast cancer, breast cells, or even in the glial cells, where it is going to affect. One thing is for sure, and you will see in many of the results, that one of the major risk factors is the obesity. And the reason for that is that fat cells, the adipose cells, are one of the storehouses for any kind of chemicals. And so that, it's the storehouse, and as it releases and all that, so that can go into all different directions. And of course, the triglycerides or the cholesterol, so those kind of things which are also associated with many of the health outcomes. So now the concept of the exposome. What is exposome? So the exposome represents the combined exposures from all sources that reach the internal chemical environment. Combined exposures, everything. You eat, you breathe, you swallow, you touch, you imbibe, anything what you do together. But how do you distinguish? How do you differentiate that where it is coming from? And then based on that exposure, your internal environment is changing. Your microbiome of the gut is also changing because of what you eat, what you breathe, how you do that. So it's changing because the microbiome helps the whole chemistry of your inside, the hormones, the neurotransmitters, which is there is a brain-gut connection. So that changes all internal chemistry. And as you can see, this radiation, air, water, people you already mentioned, diet, drugs, stress, infections, behavior, lifestyle. And then those exposures, internally, what do? They cause inflammation, they have the xenobiotics, pre-existing disease, lipid oxidation, oxidative stress. So those are being affected by these exposures. So this is one of the routes, or this is one of the possibility that we can probably work to find out what do, how do they interact internally, those exposures. So this is what the exposome and things. So it's called bottom-up exposomics or top-down exposomics. So one is, and which is very prevalent in all over the epidemiological studies, what you'll see, that we monitor what is there in the environment with all the sensors and everything. We monitor the pollutions, the ozone or particulate matter or sulfur dioxide, everything what we monitor. And we try to associate that with if there is any disease cluster, any cancer cluster which is there. So, okay, so this area has a very high level of ozone. This area has a very high level of sulfur dioxide or nitrous oxide. And then you see over the period of time, a lot of people are getting the cancer. So that's more of a the association kind of thing. You cannot directly pinpoint that, okay, this is what is causing, or is the combination what is causing. There are other approaches that you take the bodily fluids, such as the blood or urine, or that's how you kind of try to figure out. But the challenge there is that you can only test what you know that you can test. If you do not have that kind of an assay, there may be something else. But this is where the precision or the personal side which comes in, that the precision environmental medicine, and Diana Azam is working towards that. So which is a very good, this is how you can say, okay, this is your environment, this is what we are detecting in your blood, this may be your cause of the cancer. So this is precision medicine, precision environment. So that's what we are trying to. There also you look at from the genetic side. I will maybe later on, I'll ask Diana to tell what she has been doing, that she has personalized medicine for the cancer treatment. That's what she's working on for the kids. So here, as you can see, bottom-up exposomics, you evaluate uptake, metabolism, etc., important agents, what you know that might be causing the issue, and measure all analytes in air, water, food, etc. from cases. But there's so many. How can you measure everything? So, but if you have to go personally, then you can look at the blood or urine, and that's how you can monitor. And probably that will give you the complete picture. But what you are measuring, we don't know that that's all you have to measure. So there was a very, one of my, earlier professor, he used to mention that we don't know what is happening to us, but nature knows. Nature has, for nature, all of us individually, we are an experiment. So how much we can generalize, each one of us is an experiment for the nature. Yes.
So you're touching on something that as soon as you start getting exposed to research, you realize that correlation doesn't equal causation, right? And that's the big grounding of what's here. Just because we see both things kind of happening in the same place doesn't mean we understand how one informs the other. And it's always really fascinating to me that scientific research has such a high threshold to say, yes, we know this to be true, or we absolutely know this to not be true. Mm-hmm. So this is a lot of examples of what we know we don't know to be true. It may be, it may not. Can you speak to an example just as a comparison of something that we know for certain, or something the opposite that people suspect but we know for certain is not? Yeah. And what that threshold is?
Yeah, some of the which is known to cause cancer, such as arsenic exposures or radiation, or there are some which has been shown to be proven, and for that there had been a lot of animal studies which has been gone, and that has been correlated with the people who have been occupationally exposed to certain things. That's how people have said, okay, that's established. Okay, this is what is called. Yeah. Yeah. Yes, go ahead.
It's kind of referring back to my earlier question, what she said. So knowing all these, what causes what, can you give us an example of what you for example, when you go shopping and you see, okay, something with high fructose corn syrup, I'm never going to consume as a researcher who knows what causes and what doesn't cause cancer. Can you give us an example of I'm assuming you also don't smoke, but I'm interested in
How do you smoke?
food items, especially here in the US. I'm not from the US, and I find it really difficult because a lot of food they sell here is unhealthy, or I don't know, because if it causes cancer, but it just, when I can't pronounce the ingredients, it's just weird to me.
Yeah, again, I cannot pinpoint. However, what I can say, but what I can say is it all depends on the magnitude, the frequency, the duration. How much? Even salt can be like, if you are taking too much, that's going to cause problem. If you are having too much of sugar or any kind of thing which is there, so magnitude, frequency, and the duration.
But I don't think scientific. The question is, like if you go shopping, do you buy pollutants?
I try to buy as healthy as possible, but then also I have to look at the cost.
Do you look at the ingredients?
Yes, I do. I do. Like
What's something if you see you will never buy?
Like for example, the shampoo. If I have stopped buying for the paraben, when I see the parabens, I'm not buying it.
Let me make a comment just to follow up on what Dr. Deoraj was saying about environmental precision health, right? So we're all different genetic makeup, everything about us are different. The microbiome, we all agree we're different, right? So if we all get exposed, let's say, God forbid, you and I get exposed to arsenic. We know arsenic induces cancer. There's evidence that you put arsenic on a cell, give it some time, it will induce cancer. If you and I both are exposed to arsenic, do you think we both are going to get cancer? The answer is no.
Not necessary.
You know why? Because your genetic makeup is different than mine. So I may have more genes that protect me or may be able to repair the damage that arsenic is going to induce in my body, but yours didn't. So what I'm trying to say is that this field is emerging now. We don't know a lot about how the environmental exposures, the exposomics, affect each individual person. So that's the type of work that Dr. Deoraj and many toxicologists in the field are trying to understand. And why can we understand it today is because we have the tools that we can use to add all these compounds onto cells directly, quickly, try to measure what happens over lifetime. There's a lot more studies to do. So we don't know the answer yet, but we're starting to identify the gene-environment interaction.
Yeah.
Okay?
Thank you. Yeah, so, I mean, just following up what she just mentioned is like even siblings, even twins, they're living into the same environment, they will have completely different health outcomes. They're eating the same food, they're living into the same environment, but they will have a different outcome. We are all different.
Just a follow-up question to your comment. Do you foresee a time when we will be able to see the connection between, the gene environment and the environmental?
Deoraj mentioned my work on precision medicine on the treatment part, not the environment part. And today we can identify what works for each individual cancer patient because of the tools that we have. We can get cells from the tumor, test hundreds of drugs directly on tumor cells from each patient, give back results in a week, try to identify what works for each patient. That's what we've been doing in childhood cancer, for example. So all of that has been really available because of the tools and techniques. And I believe environmental precision health is going to rapidly evolve because of the tools that we have.
Yeah, we'll be talking about like what we have, AI or the modeling and all this kind of things which is happening. Yeah, so all those things which is happening. So this is how you will go. And then, so as I just mentioned earlier, that the chemicals or any kind of environmental factor which you get exposed to, they may have antagonistic effect that may even nullify each other, or they may have a synergistic effect. When they break down, even sometimes some of the chemicals when you get exposed to, they may not be that harmful when you get exposed to, when you eat or when you breathe, but when it goes in the body, when it breaks, the body breaks it with the enzymatic system, that may become much more potent carcinogen. Or it can be even it will completely nullify it. So there's so many things which goes in our body, it's just hard to pinpoint. So, and then of course the age and your physical stress or health status all determines how you are going to respond to it. Again, this is definition of exposome and exposome versus genomic complexity. So here the exposome includes over 100,000 exposures. Over 100,000, it could be 200,000 depending on the person. It's just an example. And we have 20,000 genes, 20 to 22,000 genes. And they are not all involved into detoxifying it. They have all different kind of jobs, different things what they do, from the development to maintaining your heart rate, or all kinds of physiology. So these 20,000 genes, how do they interact with our chemicals, our exposures? So that's like exposome versus genomic complexity. Interplay between environmental exposures and genetics influences cancer development and prevention strategies. We kind of much more elaborated already on that part. So the exposome framework promotes integrative research in molecular toxicology and public health for cancer prevention. So that's the idea, that we have to take a holistic approach. We have to, exposome provides that venue, that how we can approach that part. Whether that will be complete, because ultimately, to me, it looks like that might be a model. It will not be foolproof. Even if, let's say 70% of times it's correct, that's great. If it's 100%, fantastic. This is, so now I'm moving into the epigenetic side. Yes, go ahead.
Yeah, since we are, since this is global learning, could you, I'm sorry to interrupt that, but could you talk a little bit about, how cancer, how you see cancer from a global perspective, either, geographically, are there areas of the world where people are more exposed, or however you want to define that?
It's the Asia at the moment, which is like sitting on the time bomb. Reason is also the very high dense population, as well as, and not only in Asia, any country which is in war, conflict, or even I would say to some extent where the development is taking place. Many of the countries just trying to emerge as a developing country or the developed country, a lot of developmental activity which is taking place. Imagine all kinds of exposure people are getting. So that is why this topic is so relevant at the time, that we are just sitting on the tsunami of the cancer which is going to come in the next 10, 12 years. And I can give you an example of India. 1960s, that's when we had the Green Revolution, right? That's when we had the Green Revolution. And today, that particular part of India where we had the maximum production, all this is the area of Punjab. From there, we are running a cancer express train, which takes cancer patients to the cities where they can be treated. So my point here is that wherever the development takes place, it goes hand in hand. Even the spread of the diseases is very closely associated with the development. Take an example of Ebola. When it came up first, it was very confined, but this time when it was emerged, it spread all around. Many, many places it went because of development, the travel, and all those people have access to the urban areas. So the development and as well as the densing population, urbanization is another issue. Where we live into the cities, so earlier maybe 40, 50 metropolitan cities which were there in the world. Today we have at least 400 metropolitan cities. The people who have thronged to those cities, they live into such a situation. Their living conditions are not good. The kind of water they drink, the food they have access to. So those people are getting exposed, and that's, it is going to take time, but this is going to happen. And that is why, that was one of the reasons, I'm glad you asked that question, one of the reasons I wanted to talk about cancer. The cardiovascular disease is at the top at the moment, but we are just sitting on this time bomb that just 10, 12 years. That's what I'm thinking is that's going to happen. And then also, interestingly, you will have incidence and death much more because the healthcare is not there to support it. In low-income countries or middle-income countries, the death will be less into the high-income countries. So this is another thing, that the DNA is not your destiny. It contributes only 5% towards cancer or 2% towards cancer. It's how your DNA or gene environment, how it interacts with your environment, that's what determines what's going to happen. And that's where the science of epigenetics come into play. It was a very famous saying which says that our DNA is a loaded gun. It's the environment which fires it. So, and it's interesting that it fires not only at the physiological level, it fires every cell level. It's a microenvironment which cell gets to interact with. The genes, all cells has 20,000 genes. They can be fired at different times, they can be fired at different stage, and that all depends on what kind of environment those cells are. So this is the core concept of DNA versus the switch. This is epigenetics. It's, as you can see, DNA is an on or off switch. The positive environment, you have a protective genes, 85%, which is working towards a negative environment, poor diet, chronic stress, harmful genes. And from choice to health outcome, lifestyle, epigenetic change, gene activity, and disease. So this is, again, the gene environment interaction cancer. This is just an example which I'm presenting here. As you can see, smoking or other exposures may contribute formation of adducts. Polyaromatic hydrocarbons, pyrene forms adduct with DNA. Mutations cause mutation 3. And here, who are susceptible population? If you have a poor diet, age, health status, AIDS, immunocompromised, genetic predisposition, gender, ethnicity, all those things contribute towards the development of cancer. So, we know that we all are here. Every day we hear something. Everything like, oh, you are sitting like this for a long time, that's going to cause cancer. If you drink in that kind of a bottle, that's going to, if a steel is going to give you a cancer. Everything, and every day something new which says, okay, this is going to cause cancer. And at the same time, every day we have new diets. Okay, this is going to help you, it's going to detoxify you, this is going to, cure all kinds of problems and everything. But here, I will just make a statement here is that all these things what we have, it has a very short life. Maybe 10 years, 5 years, 20 years. We don't know the complete picture of it, that what actually might happen 20 years down the road, 40 years down the road. There are certain things which we have been exposed and our body is able to take care of it. Maybe our body will evolve after maybe hundreds of years or 200s of years, which can tackle this plastic as well. There are bacteria and all that which can tackle some of them, and they're even being genetically engineered to do that. So hair-raising headlines about environmental contamination, that it can be hard to judge what is new or newly alarming. This is again from the article. So this is also hallmarks of cancer. What happens when the cancer has to develop? These are some of them. First of all, they start to grow uncontrollably. Each cell is a process called apoptosis. It's a programmed cell death. They come out, they are programmed to die. But these cancer cells, they stop dying. They just continue to grow. And these are some of the hallmarks, as you can see. Accumulate changes in the genetic material, grow uncontrollably, escape cell death. They become very stubborn. They don't die easily. Then you have increased nutrient and oxygen supply to the tumor, evade the immune system, increased blood vessel formation toward the tumor. So this is how they start to develop cancer. And it's a collection of it's not just a linear disease. It's a collection of disease. And it also happens in terms of, you can think about that the cells of any particular organ are different stages. And they can start from any stage, what you're looking. But these are some of the hallmarks of the cancer that which has to have for cancer to develop, to form the tumor, to metastasize, to become malignant. Which organ it is going to be, it all depends. So this I'm just going to give you some example of some work which I did. This is it's a precocious puberty as a risk factor for reproductive cancer. That was one of the theme of my work. So what I did is that I collected the data from the Florida Department of Agriculture. This is a 2010 data, and all these insecticides which is being used in the Florida fields, fungicide, herbicide, insecticide, other chemicals, and some of them are also the endocrine disrupting chemicals. And so, and then we have it's called comparative toxicogenomic database. From there, what I found is that they can cause precocious puberty or delayed puberty, or many of them are common. Now here you see that how the mixture can work. So that's what I just want to highlight here is that some of them are specifically to the precocious puberty, some of them are delayed puberty, but some of them which are common, which may go in either way. Then also in the left panel, these are some of the genes, as you can see, how they are being activated, and these how they are being suppressed. And then after that, when I plotted the network, this is how the network looked like. And there are many of them which are the part of the precocious puberty. Because onset of the puberty, that's when it happens. So this, don't look at the left side, it's quite complicated. But so here also, I'm just trying to figure out that you see BPA, environmental phenols, and parabens, like there are genes which are unique to those, and there are some which are common to all of them. And this is, again, this is for the prostate cancer work. So this is what we have to comprehend what happens, the demographic data, affected biological processes, health outcome, demographic factors. And then this is where we have now tools, the AI or new data analysis tools and all that, by which we can tell that this may alone or together or in a mixture, they can work towards causing the cancer. So what are we supposed to do now? So this is where we have to work towards AI enables the processing of complex high-dimensional exposome data for deeper insights, personalized risk assessment, and public health tools. That's where it will go. This also, as like in the earlier Hillary had mentioned, this ties to the even third goal of the health. But what I would also like to point out is that it's also everywhere. The environment, whether it's ocean health or food safety, everything is there, which can lead to that part. Again, we have to know that the exposures are different, the populations are different all over the world, whether it's the indigenous population or whether the people who are living on the margins. Health impact are different for the people, and there should be a global solution which is needed, where we have to have international cooperation and sustainable investments are vital to address unequal environmental exposures. So future steps to mitigate, adapt to hazardous exposures, use modern technology, prioritize toxicity level. Don't go with the amount, how much chemical or how much which is being produced. Go, even the smallest amount of the chemical can become toxic. So we have to prioritize on that basis. Develop high standard guidelines to reduce risk for marginalized populations, ensure safe use through proper education, leveling and application. And then health and environment we have to understand, our responsibility for the environment and contamination reduction, and of course, the change has to be at the systemic levels. So a path forward is what is happening now. So rising global cancer burden, this is prepared by one of my graduate student, Amanda. So rising global cancer burden, environmental mixtures, emerging evidence and tools, whether it's the molecular toxicology, new data analysis tools, the AI, we can utilize mechanistic insights. We can get the mechanistic insight that how it is spreading, how it is doing it. Then call to action, shift from correlation to causation. So ours says don't show that there is a correlation or association. We have to move towards the causation. Address environmental degradation, social inequities, and climate instability, and then it will be reduce cancer risk. And this is what we have to do. Do you remember this? Right? From there, we have to go here. But still, it will be a model. Thank you very much. And here, I have this thing here. This is our department, Environmental Health Sciences, and I invite any of you who wants to join us. We are going to give a laboratory tour. Dr. Diana Azam, as you can see, she is also in the picture here. So, and it will be anybody who is interested. I would be very happy to. I have students going to the laboratories. Thank you.
Question is, why until now, 2025?
We are getting there. Getting there, yeah. We can't have, as we talked about, how much variation is there, human population. We cannot generalize it. Some people look at this part. Now we have we are managing it. So that's why we have the death rate which has gone down. Earlier, when you have a cancer, it's a death sentence. But people are now living 5 years, 10 years, 20 years. So there is a cure. It's being management. It's just managing. So, and maybe the lifestyle and all those things will need to be changed. Diana, you want to make a comment?
Cancer is not one disease.
Yeah.
Everybody knows exercise is good for you. Well, now the studies show that exercise actually is important because it secretes cytokines that help protect cells from damage. So when you hear these lifestyle modifications, they're important. Exercise, alcohol. There's a paper that came out showing that you shouldn't consume alcohol because it does increase the risk of cancers in women. Can I stop myself from a glass of wine? It's very hard. But yeah, there's a lot of studies showing that lifestyle modifications reduce our risk to cancer. So yeah, I would say exercise, alcohol, carbs. The microbiome plays a huge role in how you protect your body. So to have a healthy microbiome, you have to eliminate carbs, you have to increase your intake of protein. So everything, all of that, all the things you hear about, they actually are important. It's not just
I just want to add one comment. The treatment, that any treatment for that matter has to have three elements, especially in the global perspective. First of all, whether you have a treatment available, right? There may not be treatment available. You have to work towards it. The second is whether accessible. If we have, let's say, for example, Diana's treatment or precision medicine is available here. But if someone or some child has a cancer in, let's say, in Tanzania, will that person will have access to it? So then the third thing comes is affordability. Whether availability, accessibility, and affordability. Also, any treatment what we bring out has to have all these components to have much more accessibility.
Form of cancer, assuming that it's in the later stages, assuming that it's in stage 4. Is there a particular type of cancer that's the most treatable?
A lot of which is being now, again, it depends on how early it gets detected. If, as we're saying, a stage 4, it's probably too late. But prostate cancer, if it's detected much earlier, that's survival is pretty good. Many of the cancer, I would say, even breast cancer and all that, if you have early detection. There are a lot of rare cancers which we don't know even, so that we don't have any tools to detect that, to treat that. But those, as I just pointed out, the 11 most common cancer, I would probably bet on that. Okay, if you detect it early, there is a hope that you can certainly have a treatment in time, in the 5 years, 10 years, you can buy time for that.
Nice. So let's give them all a round of applause, please, for Dr. Deoraj. Thank you so much for such an insightful session and also for the awareness and the work that you do as well. I think we're all leaving here with a lot of great insight and information, and we really appreciate it. Just as a reminder, TTR continues next week. We're going to be doing another bilingual session in Spanish and English honoring Hispanic Heritage Month. So join us again next week, and thank you so much for joining us today.